to whatever week it is now. Thanks. Okay, so today geometry we're going to do 13-2 probability distribution and frequency tables. It starts on page 830. Okay, so the first thing is always we need to start defining what some of these things are. So let's start with frequency tables. Frequency tables. All a frequency table is it displays how frequent sets of data occur. Frequency tables display how frequent sets of data occur. Makes sense. So what they look like is something like this. Very often, it'll be a 2-column table. And you'll have your data in one column. Now data can be anything. It could be like, let's say we're flipping a coin, it's heads, it's tails. It could be, we're gathering information about when people's birthdays are, so it could be months. And then we have the frequency. So let's say we were doing birth months. And we did something like, well, January, we had 4 whose birthday was in there. So we'd have our data, January, and the frequency, how often that occurs, 4. Let's say February, well, we didn't have anybody, so 0. And then we go on and on and on and on. And then often you have a little box down here, which just represents the total, and you would add up all your data. So let's say we had, I don't know, March, we had 7, etc. Then we had April with 3 and May with 5. So we would just have our total, we would add them all together. So 7 plus 3 is 10, plus 5 is 15, plus 4 is 19. So a frequency table is something like that, where you have a set of data, and you have a set of frequency, or how often it occurs. Going off that, we have something called relative frequency. Relative frequency is just a ratio of a specific frequency to the whole. So for example, if I wanted the relative frequency of January, I would do my January data, 4, and I would put it over a ratio of, well, 19. Well, let's just make it an easy, let's make it 1, so this would be 20. So I get 4 over 20, which is 1/5 or 20%. That'd be the relative frequency of January. Just January over total is how we found that. Okay. Well, let's do an example. Example 1, relative frequency. So let's say we were doing music tastes, music. Then of course we have our frequency. Let's say 10 people love rock and roll. And then we have 7 people are all about that hip hop. Then of course we have country music fans with 8. We have classical with 5. We have alternative with 6. And then we just have other for 4. Well, that doesn't really look like a table quite yet, so let's make it into one. then of course, we need total. So 10 plus 7 is 17, plus 8 would be 25. Plus 5 would be 30. And plus 6 plus 4 would be 40. Right? 10, 20, 25, 15, 40. Yep, 40. Okay. I feel like I'm missing anything. Am I missing anything? Nope. Alright. So, say we were trying to find the relative frequency of rock. Well, again, I would just take my rock frequency over my total frequency. Just find that ratio. So here I have 10 people like rock, and I have 40 total. Well, 10 over 40 is simplified down to 1/4, or, as we know, 25%. So the relative frequency of rock would be 25%. Sometimes, another chart on these, they'll have a third column with the relative frequencies. I don't know if your homework will make you do that, but that's where it comes from, those numbers. Example 2. Calculate probability. Oops, shoot. So basically the same thing you've been doing. I guess relative frequency probably stays at that fraction, but it doesn't hurt me going that extra step. Okay. So let's say we're flipping a coin, and we have a whole bunch, we're flipping a coin 3 times. Flipping 3 coins. Well, and then we finally have some data. So first, of course, we flip our 3 coins, and here's the possibilities we could have. We could have heads, heads, heads. We could have heads, heads, tails. We could have heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. Alright, I got them all. Okay. And the frequency of those, let's say we have is 5, 7, 9, 6. Sorry, I got these two mixed up. Heads, tails, heads was 6. Heads, tails, tails was 9. Tails, heads, heads is 2. Tails, heads, tails was 9. Tails, tails, tails was 10. And tails, tails, heads was 2. So something like that. Now again, first step is we need to figure out our total. So our total in this case, 5 plus 7 is 12, plus 6 is 18, plus 9 would be 27, plus 2 would be 29, plus 9 would be 38, 39, 40, plus 10 is 50 total. Okay. So my question I'm going to ask you is, what is the probability technically this would be experimental probability because it's data we did of, I want to find the experimental probability of flipping exactly 2 heads. are spots where that's true, so I need to find 2 heads. And then I need to put it over my total. My total's pretty easy, that's 50. However, my 2 heads is not so easy because there's a couple you could really consider. Heads, heads, tails. Well, that's 2 heads, so I need my 7. Tails, heads, heads. That's still 2 heads, so there's 2. And then I get heads, tails, heads, which is still, again, 2 heads, so that's 6. So the times that I flip exactly 2 heads are those 3 situations. Did I miss any of them? I don't see any other ones. So 7 plus 6 gives me 13, plus 2 gives me 15. So my 2 heads, I get 15 different cases where I get 2 heads. Heads, heads, tails, heads, tails, heads, and tails, heads, heads. It's like 15 out of 50. Well, again, I just need to break it down. Well, I can divide each of these by 5, so I get 3 over 10, well, which turns into 0.3 or 30%. The next thing I want to talk about just takes those charts and goes in one step further, as I was referencing earlier. We call that a probability distribution. So, it is a frequency table with a column of probabilities. So, just like our frequency table earlier had our data, had our frequency, this just has one more column with probability. So let's say I have something real simple, like, let's see, rolling a dice. I could roll a 1, I could roll a 2, I could roll a 3. The frequency that I did that, let's say I rolled 10 times, and I had, let's see, 5 1s, 4 2s, and 1 3. Well, my probability, I would still need to find my total. 5 plus 4 plus 1 would be 10. So my probability would be 5 over 10, or 50%. 4 over 10, so 40%. And 1 over 10, or 10%. So the probability distribution would just be tacking on that third row, or third column, excuse me. Example 3, probability distribution. So let's say 50 people shot 6 arrows. 3 had no bullseyes. 5 had 1. Let's see. 7 had 2. 7 had 3. 10 had 5, and 7 hit all 6 bullseyes. Find the probability distribution. Okay, so right now the way our information is laid out, it's just written in words, and in my case some shorthand scratch. That's not exactly going to be the best towards conveying data, so we need to make a chart. So our chart, of course, we get the number of bullseyes hit. We obviously get our frequency. And then at the end, we need to find the probability distribution. Okay. Well, we can either hit 0, 1, 2, 3, 4, 5, or 6 bullseyes. So 0, 1, 2, 3, 4, 5, or 6. Okay. I know my chart's a little crooked. Sorry about it. Now we're going to fill in our information. Well, frequency, how many people hit exactly 0 bullseyes? Well, we said earlier that was 3. We saw that how many people hit 1 bullseye? That was 5. How many people hit 2? That was 7. How many people hit 3? That was also 7. How many people hit 4? That was 11. How many people hit 5? That was 10. And then 6 was 7. And as we said earlier, 50 people shot, so you should have a total of 50, so let's double check that. 3 plus 5 is 8, plus 7 would be 15, plus 7 would be 21, I'm sorry, 22, plus 11 would be 33, plus 10 would be 43, plus 7 would be 50. So again, total of 50. Now probability distribution, all you gotta do is my number or my total, 3 over 50, which we can type in our calculator and find the percentage is 6%. When it's easy, something like 50, well, what do I have to multiply 50 by to get to 100? By 2, so I can multiply my numerator by 2. 5 over 50, or 10%, then I get 7 over 50, which again, if I went through all the steps, or if I multiplied 7 by 2, I would get 14%. 7 over 50, if it was 14 over there, it's still got to be 14 here. Then I get 11 over 50. Then I get 22%. I get 10 over 50, which is 20%. Then I get 7 over 50, which is 14%. Now to double check this, I would just add up all those, and what percentage should I end up with? Well, naturally I should end up with 100. 6 plus 10 is 16, plus 14 gives me 30, plus 14 gives me 44, plus 22 gives me 66, plus 20 gives me 86, plus 14 gives me 100. Okay, so that's all I got for you on 13-2. Those are all 3 examples in the book. Just keep working hard with everything that's going on. Thank you.